Hello everybody, my name is Chiavassa. I do work in Nice, the Observatory of Côte d'Azur, and I'm visiting scientists right now at ESO for the current year. I do work on Evolved Star in general, and I will present briefly the Gaia astrometric incertitudes, how this incertitude can help us to extract the physics and the stellar parameter for Evolved Star. I include here the people I work with. So we see in Gaia that during the difference, so these are plot from the Gaia here too, we see that several stars actually do move a lot during the, they apparently have a movement of the photocenter during the Gaia coverage mission, and these stars are actually long period variable. This long period variable have large amplitude and luminosity and variability in time scales covered by Gaia, and are mostly AGB and red supergiant stars. What are these red supergiant and AGB star? Sure you already know this, but I will try to repeat briefly. These evolved stars actually are major cosmic engines that actually enriched with chemistry and building blocks for the next generation of planets. So it's very crucial to understand how these stars eject material and how much material they eject. Here I included the stellar parameter of the star. So how do you actually can try to interpret these observations, the observation with Gaia? I introduce this with the model. So we do simulation of that we call the star in a box simulation, where Euler equations are solved numerically, and then the star, the thermodynamic structure is used to compute interferometric, spectroscopic, photometric, and astrometric observables. In the case of Gaia, what we have here is a synthetic image of an RGB stars from the paper of 2018. So we see that the photocenter is actually moving. So the barycenter position is the dashed lines, and we see that actually during the Gaia mission, so this is a simulation over 5 years, we see that it is moving. If we actually see this movement like as a predictive photocenter displacement, this displacement up to 5 to 10%. It depends on the star we're looking at. So basically, the star is moving, is apparently moving by physical properties of the star itself and not by measurements. If you compare this now to Gaia observation parallax on y-axis as a function of luminosity, we see different points, the black points with error bars from Gaia observables, and the stars are the standard deviation of this photocenter displacement that we just saw. We see actually that the convection related variability accounts for a substantial part of Gaia DR2 parallax, and is even better when we go with the Gaia early DR3 data, where actually the star, this inserted in Gaia measurements actually really coincide with what we expect in the simulation. Now that we have this standard deviation for the center, we go to the theory now. Using the simulation, we see that the standard deviation for the center displacements actually is correlated with the log of the pulsation, as in the first plot here. So this gives information about the stellar mean interior properties, but also with the surface gravities, gives like information about the granules that cover the star. And this is a unique way to determine mass, radius, and convection properties of AGB stars and red supergiant. So what's next? What we plan to do in the next year, what we are doing right now, is to study the photometric and radar velocity at the same time. This is work in progress because actually there is a variability also in this case. Here we have an example for red supergiant, where this the BP and RP Gaia part are actually fluctuating, so is the gray line. Then extend the 3D global simulation to increase the number of objects we want to look at and go to the part of the Gaia incertitude we have, so to cover more stars, and study the dependence at the end when Gaia DR4 will be out, the time-resolved Gaia observables on stellar mass and radius to construct a unique recipe to derive fundamental parameters for these kinds of parameters. And so eventually we will actually study systematically the properties of convection in other stars than the Sun. Thank you. I'll leave you with this announcement for a postdoc in my group. If you want to come, just drop me an email.